So we said that we were going to have other ways of expressing concentration, and one big one is molality. When molality had a definition of moles of solute over mass of the solvent. A lot of times, this is not what you're given. So we have to know how to create these different portions so that we can figure out what the molality is. Now, if you're given the mass of the solute, you divide by the molar mass, and that will give you the moles of solute. And this is something you should be used to doing because it's what you had to do for molarity as well. Okay, so this one should be familiar. We could be given the volume of the solvent directly. How much liquid did I use to dissolve this? If that's what I'm given, I need to have the mass, not the volume. And I can fix that problem by multiplying by the density of the pure solvent. See how this is in a violet shade, and so is this, or a lavender? Mass of solute over volume of solution, that was our old friend molarity. If we had those, we could create this part, moles of solute over volume of solution, and get molarity. Well, now we do this part the same, but this is done differently. Since this is the volume of the solution, and I'm looking for a mass, what I can do is I can multiply by the density of the solution, and that will give me the mass of the solution, which still isn't what I need. What I need is mass of only the solvent. But that's okay because I had been given the mass of the solute. So I can just subtract that off, and the only thing left then would be the solvent. And then I'm ready to proceed to molarity. So we'll do a problem or two. But here is a question. What's the molality of a solution prepared by dissolving 78.2 grams of ethylene glycol in 1.50 liters of water? It says we can assume what the density of the water is, and we're given the molar mass of the ethylene glycol. So that's nice. What do we want? Well, we're trying to find molality, and the definition is moles of solute over kilograms of solvent. So let's take care of moles of solute first. All right, they told us the number of grams. And they also told us what the molar mass is. So I'll just flip that upside down. 1 mole would be 62.07 grams. And you can see the grams will cancel and we'll end up with moles on top. On the bottom, it says, I want the kilograms of solvent. They gave me 1.50 liters, and it's pure water, and they say the density of water. So they say 1.00 grams per milliliter. So 1,000 milliliters per liter. And then that will take care of those. I will have this in grams, and I really want it in kilograms. And you're going to find out after all of that that it was just 1.50 kilograms. And that's what we will put in here. Now this will be in moles per kilogram, which is the definition for molality. And I can run it through my calculator. And the top part becomes 1.26 moles. The bottom part is the 1.50 kilograms. And this will become 0.840 molal.